On March 11, 2011, a catastrophic magnitude 9 earthquake shook Tohoku, Japan. We had another disastrous event, the Noto Peninsula earthquake of magnitude 7.6 on January 1st, 2024. We are determined to significantly enhance disaster preparedness and reduce the toll of future natural disasters beyond our generations and worldwide. For that reason, we will share a series of slide videos on 1. How we found the genesis processes of significant and megathrust earthquakes from chaotic and noisy seismic data. 2. How can we use them for real-time predictions and mitigation worldwide? I am Fumi Takeda, and I am creating the slide videos. The video's title is Significant and Megathrust Earthquake Real-Time Predictions, Smart Predictions in short. I am also leading Takeda Engineering Consultant Company, Tech21, in Hiroshima specializes in engineering solutions with innovative tools named physical wavelets. Earthquake Prediction Institute, AP21, in Imabari focuses on prediction and mitigation and explores self-sustaining communities fortified against natural disasters. Tech21 and AP21 are dedicated to advancing disaster preparedness for the 21st century and beyond. Because of the Tohoku catastrophic events, I established AP21 in 2016 to mitigate earthquake and tsunami disasters for our communities. Smart predictions are detailed in the following archives by Takeda. 1. Tsunami and Megathrust Earthquake Disaster Prevention Warnings, 2023. 2. Significant and Megathrust Earthquakes Real-Time Predictions, 2022. 3. Observations of Large Earthquake Genesis Processes, 2022. 4. GPS Observations of a Megathrust Earthquake Genesis Process, 2021. Please visit the archive website for the updated versions. Physical wavelets are the Newtonian intellect at the heart of smart predictions. They unravel the fundamental principles of force, mass, and acceleration, denoted by the equation F equals ma for complex and noisy time series data. This critical insight allows us to issue timely disaster warnings. Physical wavelets function as Newton's lens of F equals ma and unveil real-world dynamics. In the real world, we find industrial systems, health monitoring systems, financial market dynamics, environmental systems, natural hazards, and genomic analysis. We can observe each section emitting information in time series data as follows: flow, pressure, temperature, vibration, and motion, arterial wall motion, ECG, and autonomous nerve activities, market activities, earthquake data and crustal deformation, and genetic sequences. Through the Newton's lens, we can identify each F equals ma process for predicting and preventing catastrophe, providing blood pressure, artery stiffness level, ECG, and heart rate rhythm at home, predicting markets, predicting earthquake and tsunami for mitigation, and studying cancer, genetic disorders, and evolutionary biology. For over 3 decades, I've leveraged physical wavelets to prevent catastrophes in industry and healthcare. We now look at the natural disaster section. Through Newton's lens, the Geospatial Information Authority of Japan, GSI, GPS daily displacement data reveals 1. A 300-year history of strong plate coupling with the Pacific plate moving twice the fingernail growth rate. 2. A sudden emergence of bulge-bending deformation. 3. The East Coast's pulling of the Pacific plate. A tweezer mimics the pulling at this cross-section. Picture a 300-year-old regular deformation suddenly morphing into a tweezer. We push the tweezer to mimic the West Coast's push. The push makes the East Coast pull the oceanic plate. Nature makes fantastic magic on the Tohoku crust dynamics with the tweezer's movement. The GPS observation for the last 3 months up to the Tohoku event reveals 1. The East Coast began pulling the Pacific plate on July 11, 2010 by the West Coast push. 2. The Pacific plate reached its peak speed 3 times normal on December 22, 2010, causing a magnitude 7.9 earthquake in the oceanic plate. 3. The east coast then began decelerating the Pacific Plate's westward motion. 4. The east coast stopped the Pacific Plate on February 21, 2011 and, 4 days later, reversed the movement and began preparing to return the bulge-bent crust to its normal state. Another 14 days later, the returning preparation led to the Tohoku event on March 11, 2011. Daily predictive information and disaster mitigation measures are based on the data collected at 3 islands in the Pacific. We unravel Tohoku's subduction zone dynamics with elegance and depth. Newton reflected, nature is pleased with simplicity, encouraging us to look for natural elegance. Yet, Einstein cautioned, make everything as simple as possible, but not simpler, warning against oversimplification. The simplified model is that the Tohoku crust coupling with the subducting Pacific Plate resembles tweezers movement, reflecting the subduction zone dynamics. The oversimplification is a mere recoil against the oceanic plate movement. We apply F equals ma to demystify the Tohoku earthquake's complex genesis process with nature's simple magic. Let's delve into this 300-year-old crustal deformation pattern using an Earth-fixed coordinate system to guide our observation. Over a decade of GPS monitoring in the Tohoku subduction zone has revealed 1. The west coast's overriding plate moved eastward at 16.3 millimeters per year and upward at 1.4 millimeters per year and southward, toward you out of the screen, at 13.3 millimeters per year. 2. The subducting Pacific Plate beneath moved west at 40 millimeters per year, about as fast as our fingernails grow. The oceanic plate moved northward, toward the screen, at 11 millimeters per year. 3. The east coast fault coupling moved the east coast westward at 16.6 millimeters per year, downward at 6 millimeters per year, and southward at 8 millimeters per year. 4. The area's top, ridge, moved eastward at 2.1 millimeters per year, upward at 0.6 millimeters per year, and southward at 9.4 millimeters per year. Analysis of coseismic shifts and deformation rate suggests this deformation pattern has been consistent for 300 years. However, a sudden transition from this regular to a bulge-bending deformation changed the regular subduction zone dynamics. The bulge-bending deformation is a slow bending of 15 months width. First, a bulge downward by a few millimeters against the oceanic movement, and then upward by a few millimeters. The deformation reveals that pushing the west coast pulls the Pacific Plate. Physical wavelets revealed nature's magic on the Tohoku subduction zone dynamics with a tweezers movement. Bulge-bending deformation of 15 months before the March 11, 2011 Tohoku magnitude 9 earthquake. A downward bulge grips the fault, begins pulling the Pacific Plate in July 2010, and accelerates the pulling until December 22nd. An upward bulge lifts the Tohoku, decelerating the pulling and reducing the static friction force on the fault surface by the lifting began in November 2010. The west coast eastward push with the bulge lift triggered the Tohoku catastrophic events on March 11, 2011. The eastward pushing force surpassed the static friction force on the fault surface because the bulge lifting force reduced the static friction force. The push then decoupled the plates, restoring the bulge-bent Tohoku to normal. The most effective real-time warnings and mitigation measures come from the oceanic plate motion driven by the overriding plate. Our upcoming video of smart predictions will guide you on how physical wavelets observe the genesis process of the Noto Peninsula earthquake of magnitude 7.6 on January 1, 2024. Through the lens of physical wavelets, similar to those for the 2011 Tohoku earthquake, smart predictions illustrate how SMART could have provided daily disaster warnings to the communities over 3 months before the event. SMART will delve into subduction zones, focusing on the Nankai Trough, Sagami Trough, Chishima Trench, and Cascadia, emphasizing our commitment to help strengthen community preparedness. As we continue to unravel the magic of nature, your support is vital. Subscribe to our channel and join us on our journey to withstand natural disasters. Together, we can be prepared.